Section 8.6 is on interval notation. Our objective is going to be to solve inequalities and write their solutions using interval notation, which is a fancy way to do inequalities, and hopefully that'll become a little more evident as we go here. Okay, in the number line the old way, if I had x is greater than -1, well, hopefully no shock to you guys, I'm sure, that we'd put an open circle and then an arrow going off to the right to show that. Okay, with interval notation, the graph itself is not going to be much different. We're still going to have an arrow going off to the right, but instead of an open circle, what we're going to use is a parenthesis, and the parenthesis is going to open in the direction that the arrow goes. So basically what we'd have here is something like that. Not a great parenthesis, but I think you get the idea. Okay, the way we write it, instead of this inequality using a variable, we're going to use a notation to show basically the starting and ending point of the interval that we're talking about. And so basically what we do is we're going to put down the starting number and then the ending number, lowest number on the left, biggest number on the right. And so this one starts at -1. It's a pretty small negative sign there. There we go. And then separate them with a comma. And this one goes all the way to the right forever, so that goes to infinity. Okay. And whatever notation we use down here in the number line is the notation basically we're going to use here. So the starting symbol is a parenthesis, so that's what we're going to use here, an open parenthesis. And then we're going to go all the way to infinity. Well, we never quite make it to infinity, so we're just going to use that same thing. We don't quite make it to -1 on the left, and we don't quite make it to infinity on the right. And so there would actually be how to write this inequality using interval notation. Okay, as soon as we introduce a or equal to bar and a less than sign, things change a little bit, of course. Okay, and we're used to seeing the solid dot in this case and then the arrow going off to the left. Again, not a big shocker. Okay, and again we're going to have to do some kind of notation to differentiate what's going on here, and so we're still going to use an arrow going off to the right, but we need to do something different than a parenthesis to show the or equal to that 4 is actually included. And instead of a parenthesis, we're going to use a bracket here. So square it off nicely. And again, we want to be able to write an expression similar to the one above here to show that we're going basically all the way starting at -infinity, coming up to 4, and then stopping at 4. So again, our low number is going to go on the left, which is our -infinity, and then separating with a comma. Well, eventually make enough dots, it looks like a comma, I suppose. And then it goes all the way up to 4. Okay. And again, we just use the same kind of notation that we have in the number line up here with our expression. So we use a nice bracket around the 4, and again we don't quite make it to -infinity. So anytime you use infinity, we're always going to stick with a parenthesis. We have kind of a mix of symbols there. With compound inequalities, well, the old way we'd write it similar to what you see on the screen there, with -2 less than x less than or equal to 5, which basically means x is between -2 and 5. It does include the 5, but does not include the 2. Graphically, we'd put the open circle on the 2, nice line connecting to a 5, where we would put a nice solid circle to show that. Okay, the interval notation again is going to be a little bit different between different types of circles. So just like before, with the open circle we'll represent that effectively with a parenthesis, and on the closed circle we'll represent that with a bracket. Okay, and again we're just going to shade in between them, or draw the line in between them like we did before. So there's our interval notation of compound inequality. Again, to write it more algebraically instead of graphically, we basically just take the graph and smush it into an expression, and that may not make a whole lot of sense, but we have a parenthesis down here at the bottom that's on the -2, so you put the -2 inside. My negative signs are working well today. And then comma, and then from there it goes up to the 5. And again, it's bracketed because we are including the 5. That's a little sloppy, but that's what it looks like. Now, with solving inequalities, nothing much is going to change in terms of the work that you do. Just the difference here is going to be the way you express your answer. So with this inequality, you have basically 4 choices of what you want to do. I'm a big fan of getting rid of the smaller variable first, so I'll subtract 5x from both sides, give me -16 is less than 2x plus 12. Okay, subtracting 12 from both sides gives me -28 less than 2x. And then finally dividing through by 2 gives me -14, there you go, is less than x. Okay, now granted that's a little bit awkward having the variable on the right hand side, so my advice would be to just switch it around, have x, and make sure Pac-Man is still eating the right thing there. So x is greater than negative 14 is probably a different way to say that, or a better way to say it. And now what we want to do is again translate this into interval notation. And so on the number line, of course, we're dealing with negative 14 as the value in question. There you go. And then from there again we want an open circle, arrow going off to the right, but really we don't want an open circle, we want that parenthesis instead. So it's looking like that with the parenthesis, and the arrow again going off to the right is what our graph would look like. But again, we're starting at negative 14, and then we're going all the way up to positive infinity. So again, bigger numbers always on the right, smaller numbers always on the left, and then use whatever appropriate notation as far as symbols here. Okay, again, we're not including negative 14, so we want to use an open parenthesis, and you never make it to infinity, so you want an open parenthesis there as well. And so this would be the way to write the interval notation answer for that. Now be careful of compound inequalities. It's basically a three-sided inequality, and you can deal with it by just doing the same thing to all three sides until you get the variable by itself. Okay, in a situation like this with the variables though, some people start panicking. I personally would just add 7 to all three sides and be done with it in one step. But just to show what you could do if you do have fractions throughout and it wouldn't be such an easy one, basically I would advise canceling the fractions by multiplying all three sides by whatever the common denominator of those fractions would be. In this case it would be 10. So I'm going to multiply everything by 10. So effectively a three-tiered distribution, or whatever you want to think of it as, but whatever the case, the 2/5 times the 10 as it comes across would give you a 4. Okay, then we got our less than sign, and then the 10 distributes into the x minus 7, and that is something that people tend to forget, so that gives you a 10x minus 70, and then less than or equal to, distributing that 10 or multiplying the 10 into the 9/10 would give you simply a 9. Okay, now from here, I'm going to get a little lazy on you here and just add 70 to all three sides and then divide through by 10 all in one step. And what that will ultimately give us is a 7.4 less than x less than or equal to 7.9. Okay, feel free to throw a couple extra steps in there if you need help seeing the work, or ask me in class if you didn't quite follow that. But once we got this, again, we want an interval notation answer instead of this. Okay, so, and the graph, 7.4 is the lesser of the two numbers, so of course we want to put that over there. Oops, got the wrong thing out there. And then the 7.9 is on the right, so actually our solution set is a fairly thin piece of the number line. Alright, and again, we want to go with the parentheses and brackets to indicate the starting and ending points of this thing. So parenthesis there because we don't have the or equal to bar, bracket here. Okay, that's kind of a bad bracket, but let's pretend it looks good. Alright, and then we'll just shade in between them, so there's our number line. Although I confess I'm less concerned with the number line and more concerned with the interval notation. So again, translating that into interval notation, we would have a parenthesis to show that it starts, putting your lower number in the left, throw the comma in there to separate the two. 7.9 is our largest number, and then we're including the 7.9, so we put a bracket on there. And there is our answer into interval notation. Of course, there's no directions here specifically to say whether it should be fractions or decimals, so I would accept either a fraction or a decimal version of these depending on what you prefer. Alright, anytime you see an absolute value inequality, what you have to realize is that's actually a compound inequality written in disguise. And I know you've done these before, so just briefly to go through this. If you see this, you got, first of all, two things to work out. The first one is if you just imagine the thing right as it is minus the absolute value symbols. Okay, the second option is you maintain what's in the absolute value symbols, but what you do from there is you're going to reverse both the inequality and the sign and the number. So now this is going to become a less than or equal to, and then it's going to be a negative 4. Okay, trust me, it's a negative sign there. I'll just make a lot of dots because I'm getting irritated with this thing. Okay, so from there pretend that's a negative sign. Okay, And then from there we need some kind of a conjunction word in the middle. It's either an and or an or based on this sign. If it's written in the format with the absolute value on the left and you have a greater than sign, that's always going to translate into an or. Okay, you can have an and for a less than sign, but we'll get to that later. Okay, now these are pretty simple to solve. Adding 6 to both sides here gives me x greater than or equal to 10. Then we have that or in there, which is actually pretty important. Adding 6 to both sides here, we have x less than or equal to 2. Okay, now from there, we can translate that onto the graph, and if you think about putting the low number on the left, which is a good idea, more than a good idea, you have to do that, and then the 10 on the right. Okay, and we want to go greater than 10, less than 2, so actually our arrows are going to take off to the right from 10, and the left from 2. And then using the appropriate symbols on here, they're going to be both the greater than or equal to type symbols, so what we want to use, or less than or equal to type symbols. So what we need to do is use those brackets. If this thing will let me draw them. There we go, there's one. And there's the other. Okay, so once we've got that drawn in nicely, hopefully again we can translate that into more of an interval notation sort of thing. And again, we're going from negative infinity up to 2, and then there's a gap, and then we're going from positive 10 all the way up to positive infinity. So a way to write this in interval notation, again, we're starting basically at negative infinity, but again, not actually reaching it, so we have to use a parenthesis there. And then again, comma to separate the two numbers, goes all the way up to 2, and now it includes 2, so we use a bracket. And then again, there's a gap, and we start at 10, and then we're going up to infinity. Okay, now there's this gap in the middle that looks a little awkward, so we're going to fill it in. And the way we're going to fill it in, if you remember from geometry, I know, flashbacks of proofs and nightmares. But anyway, one thing you did in geometry talked about union and intersection. Okay, and if we're taking two things and thinking of them together without overlapping them, that's a union. And so we're going to put a great big U in the middle of the two to show union. And that then is how you write that guy in interval notation. Okay, if you encounter an absolute value inequality and there's a number or something outside of the absolute value symbols, the best idea is in general to isolate the absolute value first by canceling whatever's out there. So here we'll divide through by -2, and I may not normally write stuff like this, but just for emphasis on what's happening, I'm going to write it in now. So we're dividing both sides of this guy by -2. So now I'm looking at absolute value of x plus 5. Boom. Okay, now keep in mind we divided by a negative, so this greater than sign now has to flip around to be a less than sign, and this gives us a -7. Okay, now if you're clever, you may have already noticed this, or at least at this step, there's actually something a little bit weird about this problem. But I'm not going to point it out yet. Leave you in suspense a little bit in case you don't see it. Alright, so going through the motions here, okay, I've got the absolute value, so I'm going to break it in two cases, and I've got a less than sign, so that's going to give us the and in between the two. So here we go. X plus, come on, there you go, 5 less than -7. Okay, and then again, and you may not think those words are very important, but there it is. And now we've got x plus 5. And now we're going to have greater than +7. Again, remember to reverse the inequality and the sign of the number on the second version. Okay, simple to solve this one. Subtracting 5, we've got x less than -12. Again, throw an and in there. Come on, give me the A. Give me the A. There you go. And again, subtracting 5 over here gives me x greater than +2. Okay, so transferring those to the number line, we've got a -12 on the left and a +2 on the right. Alright, now the problem with and is we're looking for where these two things overlap each other. And if I'm talking about less than -12, I'm talking about a parenthesis right there going off to the left, and then a parenthesis on the 2 going off to the right. So really these guys don't overlap at all. So really what we have here is almost a trick question, because I'm interested in where those two expressions or inequalities overlap each other, and they don't. So effectively what we have here is a no solution scenario. So be careful that, again, if you were paying attention early on, you might have noticed an absolute value which cannot ever be negative has got to be less than some negative number, and that just can't happen. So maybe you caught that. If you did, congratulations. If not, well, it does play out how it should as long as you're paying attention. Okay, now we've got another absolute value inequality, and there's an awful lot of stuff outside, so it's going to take us 2 steps to clear this guy out. Although if you permit me, we'll subtract 7 to get a 25 over here, and then divide through by 5 to get a 5. So after a little bit of housekeeping, if you will, we'll get 8 minus 3x in absolute value symbols, and now that'll be less than or equal to 5. So now we've got it in the format that we want. Again, absolute value means we have 2 different cases. The less than is an and. So our first case is 8 minus 3x. If we all use our imaginations, we can see a minus sign right there. And that'll be less than or equal to 5. And then again, now it's going to be an and. Again, same basic idea. We got 8 minus 3x. And now this is going to switch around again to a greater than or equal to negative 5. Okay, now the biggest thing about this one is, if you notice, we're going to end up dividing through by negative 3 in both of these, so we are going to have a whole lot of inequalities switching directions throughout the course of this problem, but here we go. 8 off of both sides here gives me a negative 3x less than or equal to a negative 3. Okay, now dividing through by the negative 3 gives me x. Again, it can be divided by a negative, so we have to reverse that. Greater than or equal to positive 1, and coming to the other side, subtracting the 8 over here gives me a negative 3x greater than or equal to negative now 13, and we're going to end up with a fraction here, but dividing through, we've got x now less than or equal to a positive 13 over 3. Alright, come on, give it to me. There you go, there you go. Alright. Okay. So again, this is what we're looking at. Now the good news is, if we want to go greater than 1 and less than the 13 thirds, okay, pardon me for writing small here, but here's the 1, here's the 13, boy, it doesn't like doing 3's. Okay, pretend that's a 13 up there, and pretend that's a 3 on the bottom. Okay, but point being is we've got brackets on these two guys, and we're looking for where they intersect each other, and if I'm going greater than 1 and less than 13 thirds, they're going to overlap in the middle right here. So there's my basic graph with some very sloppy numbers, but ultimately I want the interval notation answer, which will be a bracket on the 1, comma, 13, there you go, over 3, nope, there we go, and then close it off with a bracket, because again we're including both ends of that. And there's our final answer. Alright, there you go.